Welcome back to you students. So आज हामी implicit functions लाई कसरी differentiate गर्छ त्यसको बारेमा पढ्ने वाला छौं. But before we begin, let's try to understand what is the meaning of implicit functions. Now, let us assume that there is a function of x and y and I'm taking this to be equals to 0. What is the meaning of this? We'll try to understand later. So, एउटा function छ रे त्यो function चाहिँ के छ भन्दा चाहिँ त्यो function मा चाहिँ x र y चाहिँ mix भएर बसेको छ. Okay, x and y are mixed up. Okay, now if it is not possible to separate the variables x and y, then the function f is known as implicit functions. So to understand this, we'll take some examples. Okay, अनि यहाँ example मा भन्दैछ find the dy by dx when this happens. Okay, now let us check this one. Now यहाँनिर के गरेको छ भन्दाखेरि suppose if I take this out there, we will get 0 in the right hand side. Similarly, if I take this full thing out here, right hand side contains 0. Okay, and whatever comes in the left hand side, that will be your f of xy. Okay, now त्यति बेला चाहिँ हामीले dy by dx कसरी फाइन्ड गर्छ भन्दा चाहिँ we have to differentiate term by term. Okay, we have to differentiate term by term. How? We'll see through the example. Now here what is given? Here this one is given and we want to find the derivative, that is dy by dx. Now if you want to take this out there, that's also fine. If you don't want to, that is also fine. Now let us differentiate both sides with respect to x. So differentiating both sides with respect to x. Now let's see what happens in the left hand side. So we have d by dx of x cube y to the power 4, and here we have d by dx of x plus y whole to the power 7. Okay, since you are differentiating with respect to x, I have written x out there. Now here we have got f into g format, f into g. So here the rule is we'll keep one as constant and differentiate others, plus differentiate the earlier one which is kept as constant and keep the other one as constant. Okay, and here we'll try to apply chain rule. That means first we'll differentiate the power and we'll go inside. Okay, so let's do that. So here in the left hand side we have x cube into d by dx of y to the power 4, plus now we'll keep y to the power 4 as it is and we'll differentiate x cube, that is d by dx of x cube. Okay, so this is equal to, now let us differentiate. So when I differentiate this power, this is my n and this full thing is my x. So x to the power n format can be written as n, that is 7, into x to the power, that is x is x plus y, x to the power n minus 1. So 7 minus 1 is 6. Okay, so we have differentiated the power. Now we have to put multiplication sign and we have to differentiate the inner part. And the differentiation of x is 1 plus the differentiation of y is dy by dx. Hope this is clear to you. Okay, now let us simplify this further. This can be written as x cube into, now the differentiation of y to the power 4. So again this is 4y cube, but we have to differentiate y also. So differentiation of y with respect to x is dy by dx. Okay, so this is the first part. Now let us differentiate this one. So we have y to the power 4 here into, now differentiation of x cube is 3x squared. Now if you differentiate x, you'll get 1, right? So that's why you need not write 1 out there. So let's simplify here. So we have 7 into x plus y to the power 6 into 1 plus dy by dx. Okay, so question says find dy by dx. So we'll first open this bracket we'll open this bracket and we'll take dy by dx term to the left hand side, and everything will be sent to the right hand side. So let us open this first. So this can be written as 7 into x plus y whole to the power 6 into 1 is this much itself, plus sign. So 7 into x plus y whole to the power 6 into dy by dx. So we'll take this dy by dx term here and this will go that side. So whenever I take dy by dx here, then this can be taken outside. Dy by dx can be taken outside as common, and let's see what is remaining here. So from this part 4x cube y cube is written. So 4x cube y cube, right? And when it goes there, it becomes minus 7 into x plus y to the power 6. Okay, now let us take this part over there. So here we already have 7 into x plus y to the power 6, and when it comes here I'll get 3x squared y to the power 4. Okay, so ultimately my dy by dx will be, so if I keep it here only, then this term will go to the denominator. So I'll get 7x plus y whole to the power 6 minus 3x squared y to the power 4 whole divided by 4x cube y cube minus 7x plus y whole to the power 6. So this is my dy by dx. So this is my answer. So pause the video to note down. Okay, now let us begin with the next problem, number 2. So log xy can be written as log of x plus log of y. Remember, as I said earlier, whenever we see log without any base in calculus, the base has to be e. Okay, now this can be written as log xy can be written as log x plus log y, so equals to x squared minus y squared. Now let us differentiate both sides. So differentiating both sides with respect to, since they are asking x, so with respect to x. Now differentiation of log will be 1 by x plus, now differentiation of log y will be 1 by y. Again, let's apply chain rule out there because we have got y also. So whenever we differentiate y, then I'll get into dy by dx. Okay, let me repeat once again. So differentiation of log x is 1 by x, plus is there, plus. So differentiation of log is 1 by y, but the differentiation of y is dy by dx. Okay, now similarly let's differentiate x square. So it will be 2x minus sign say minus, differentiation of y square is 2y, but as usual we need to differentiate y itself. So dy by dx. So this part will go that side. So I'll take this dy by dx to the left hand side. So let me see what do I get. So again dy by dx is there. So from here we have 1 by y. So when it comes here, this becomes plus. So plus 2y. So whenever I take out dy by dx as common, then I'll get this much. So this goes over there. So we have 2x minus 1 by x. So this is our dy by dx. So therefore dy by dx will be 2x minus 1 by x whole divided by, this will go to the denominator 2y. Okay, so if you want to simplify this, that's also allowed. So this will be your answer. So pause the video to note down. Okay, so let's see what is happening here in this. So again the question is find dy by dx. So let me differentiate this one. So differentiating both sides with respect to x. So differentiation of e to the power x y. Okay, so let me call this to be x. So e to the power x becomes e to the power x itself. So it will be x, that is xy, into, now we need to differentiate the power, right, as the chain rule says. So that's why it will be d by dx of xy minus, so similarly we have 4 into d by dx of xy equals to d by dx of 4. Okay, now let us simplify this further. So actually I can see that d by dx into xy of xy can be taken common. So let me take that to be common and let's see what will be remaining. So e to the power xy minus 4 will be remaining here, and here I have d by dx of this much to be equals to, and differentiation of constant is 0. Now e to the power xy minus 4, let's differentiate this. So let me differentiate y first, and if I take x as constant, so it will be x into dy by dx plus, since this is f into g format, so that's why this should be plus. Now I'll differentiate x and y should be kept as it is, and differentiation of x is 1, so y into 1 equals to 0. Now it is clearly seen that e to the power from here it is clearly seen that if I take this out there and this will go over there, then I'll get e to the power xy minus 4 will be equals to 4xy. So that means e to the power x minus 4 is not equals to 0, right? So if this part is not equals to 0, then this can be taken to the denominator. Okay, so since e to the power xy minus 4 is not equals to 0, then this can be, or in other words you can say that we can divide both sides by the same number. So if we divide both sides by the same number, that is this one, which is non-zero, then what do I get? Then I'll get x dy by dx plus y into 1 is y equals to 0, because dividing both sides by this gives me this by this, which is 1. So 1 into this becomes this much itself. So 0 divided by this number gives me 0. So from here what am I getting? I am getting x dy by dx is equals to minus y when it goes over there. So therefore dy by dx is equals to minus y by this x goes to the denominator, so y by x. So pause the video to note down. Now let us differentiate this in this very same way. So as usual, differentiating both sides with respect to x. Let's see what happens. So differentiating this one, that is d by dx of xy plus differentiation of 1 is 0, so d by dx of cos of xy. Now as usual it is u into v format. So what we can do out here is, okay, so first let me keep this thing as it is. So this will be as it is, equals to, now derivative of cos, if I consider this to be my x, so derivative of cos x will be minus sine x, and how much is x? X is xy, into, now we need to differentiate xy, so that is d by dx of x into y. So let me get this thing out there so that I can take d by dx of xy as common. So if I do that, then from here I have 1 plus, and from here I have sine xy, when it goes over there, this minus becomes plus. Okay, and we have dy by dx of xy as common. So here nothing is left, that is 0. Now let us open the bracket, or let us differentiate this one. So we have differentiation of xy, so it is already done here, so let me directly write in this way. So x into a by dx plus y equals to 0. As question says, we need to find dy by dx when x is equals to pi by 2 and y equals to 0. So that's why I'm writing when x equals to pi by 2 and y equals to 0. Let us see what happens here. So it becomes 1 plus sine x is pi by 2 and y is also there, so into y is 0. So x is pi by 2 into dy by dx plus y is 0 equals to 0. So let's simplify this. 1 plus this is sine 0, so we have into pi by 2 dy by dx plus 0 has nothing to do here, equals to 0. So what is the value of sine 0? It is 0, right? So it is 1 plus 0. So 1 plus 0 is 1 itself. So 1 into pi by 2 is pi by 2 dy by dx equals to 0. So from here, what is the value of dy by dx? Dy by dx will be obviously 0. So pause the video to note down. Okay, now we'll see a new form of differentiation, and we call it logarithmic differentiation. But before we begin, let us try to understand what kind of functions will be differentiated using logarithmic differentiation. So it is said it is used to differentiate functions of the form fx equals to ux whole to the power vx. This means in this we have function of x in the base and similarly the function of x in the power also. Okay, so both base and exponent, if they are functions of x, then the functions has to be differentiated using logarithmic differentiation. Now we'll see few examples to understand it better. So in this first question, in the base we have x, and in the power, that is exponent, we have cos square x. So both contains x. So that's why we have to use logarithmic differentiation here. So first what we do here is we'll apply log. Okay, so take this to be y. So applying log on both sides. So when we apply, then I'll get log y equals to log x to the power cos square x. Now there is a formula which says log a to the power b can be written as b, this power can be written outside. So this is one formula which can be used out here. Okay, if this is my a and this is my b, then in the next step what I can do is I can write this in front. So we have cos square x log x. Now let us differentiate both sides with respect to x. So differentiating both sides with respect to x. Now the differentiation of log is 1 by y. Okay, now we need to differentiate y also. So differentiation of y with respect to x is dy by dx. So equal to is there, so equal to. Now we have two functions here, so let me call this to be f and let me call this to be g. So f into g is there, so this can be written as cos square x. So if I keep it as it is, I need to differentiate log x. So d by dx of log x plus, Okay, so now we have to keep it as it is, and we need to differentiate the other one. So d by dx of cos square x. Okay, now let's simplify this further. So this can be written as cos square x, and d by dx of log x is 1 by x, which can be written as this way, plus log x is there, so into, so differentiation of cos square. So first we have to differentiate the power. So when I differentiate the power, I'll get this much, right? Because power becomes, this x to the power n form becomes n x to the power n minus 1, that is 2 minus 1. 2 minus 1 is 1, so 2 cos x into, we need to now differentiate our cos function, and differentiation of cos is minus sine x. Okay, now let us simplify this further. We have cos square x by x minus, okay, so plus into minus can be written minus, so 2 sine x cos x. So 2 sine x cos x can be written as sine 2x, because we know that sine 2x can be written as 2 sine x cos x. So instead of 2 sine x cos x, I have written sine 2x, and we have log x out there. So therefore my derivative, that is dy by dx, will be y. So this goes there, so this divided by becomes multiplication out there, and it is cos square x by x minus sine 2x log x. So this is our answer. And one more step you can do is, you can put the value of y from here. Okay, so instead of y you can write x cos square x in the power. So instead of this you can write this as well. So this gives you the answer. Possibility to note down. Now we'll see how to differentiate this one. So again I will take this to be y. So I'll apply log on both sides. So applying log on both sides, so we will get log y equals to log x to the power x whole to the power x. So if I call this to be a, then this becomes b, so this can be written as b log a. A is x to the power x. Again we can apply the same formula here, so this x comes front and becomes x into x is x squared, so x squared log x. So I'll again write differentiating both sides with respect to x. So this differentiation of log all the time is going to be this way only. So differentiation of y is log y is 1 by y into, now differentiation of y is dy by dx equals to, there equals to, now there is again two functions, x squared log x. So let me call this to be f, and let me call this to be g. So that's why this can be written as x squared d by dx of log x plus log x. Now differentiate x squared. Okay, so simplify this. So x squared into, now differentiation of log x is 1 by x plus log x into differentiation of x squared is 2x. So again this x and x gets cancelled. So here we have x into 1, that is x. Here we have got 2 log x. So basically x can be kept as constant or common. So we have 1 here plus 2 into log x is 2 log x. So therefore your dy by dx will be, this y comes here and becomes y into x 1 plus 2 log x, and you can put the value of x as well here, so this y as well here. So this becomes x to the power x whole to the power x. So this is the value of y. So we have x into 1 plus 2 log x. So this is your answer. Now we'll try differentiating this kind of functions. अनि यहाँनिर के देख्दैछ भन्दाखेरि there's a plus sign, there is x here, and on the power there's also again function of x. So both base and power is having functions of x. Here we don't have such case, but again here we have got the same case, right? So we have got the same case. So y is a function of x because we write y equals to fx, and here in the power also we have got x. Similarly, in the base we have got function of x, in power we have got function of x. Similarly, the same thing is happening out here. Now whenever we have such kind of case, if we apply log on both sides, then we get this kind of form. Suppose if I apply log here, then I'll get log y equals to log of something, let me call this to be a plus b, and we don't have any formula for this. Okay, we have got formula for log ab, we have got formula for log a by b, but we don't have any formula for log a plus b. So in such case, what we do is we'll call this to be u, we'll call this to be v. Okay, now when I differentiate both sides, differentiating both sides with respect to x, because the question is asking differentiate with respect to x, then what do I get? I will get dy by dx is equals to, since this is u, this can be written as du by dx, plus is there, so this can be written as dv by dx, and let me call this to be equation 1. Now our aim is to find dy by dx. That means to find dy by dx I need two things, that is du by dx and dv by dx. So we'll calculate these two things and we'll put the value of du by dx and dv by dx in this particular equation to get the value of dy by dx. Okay, so we have u equals to e to the power cos inverse x. Now in the base we don't have x, so we can directly apply chain rule here. Okay, so in differentiating you will write that by yourself, so you will get du by dx. Now we have to apply chain rule here. So for exponential, e to the power, differentiation of e to the power x remains as it is, so that's why differentiation of e to the power cos inverse x remains e to the power cos inverse x. Now let's differentiate cos inverse. So differentiation of cos inverse is minus root over 1 by root over 1 minus x square. So this differentiation of cos inverse x. So therefore your du by dx becomes e to the power cos inverse x by root over 1 minus x square. Okay, so this is your du by dx. Now again, and we have v equals to x to the power root x. So in this case we have both base and exponent as a function of x, so that's why we need to apply log. So applying log on both sides, you will write that by yourself. So you have log v equals to, again this root over x constant, so we'll get log x. Now we'll differentiate both sides with respect to x. So what do we get? We'll get first 1 by v, because the differentiation of log is 1 by v, into differentiation of v is dv by dx. So it is equals to, again this is f into g format, so root x into d by dx of log x plus x into d by log x into d by dx of root over x. So let's differentiate this. So root x into differentiation of 1 by log x is 1 by x plus log x is there, So x to the power half. So this becomes half into x to the power half minus 1. Okay, because my n is half here. So simplify this. So you'll get this, and this can be cancelled, and you can write root x out there. So we have 1 by root x here, right? So plus log x plus 1 by 2. This is also x to the power minus half. That is 1 by root x. So 1 by root x can be written outside. So 1 by root x is kept outside. And from here we have got 1 plus from here we have got half log x. Okay, so this is the value of 1 by v dv by dx. So that's why from here we'll get dv by dx. This v goes to the numerator. That is, it becomes v into something. So what is the value of v? V is x to the power root x. Okay, so this is our dv by dx. So therefore, if I call this as 2, and if I call this as let me call this to be 2, and let me call this to be 3. So using 2 and 3 in 1, we'll get, therefore dy by dx will be equal to du by dx. How much du by dx? It is minus e to the power cos inverse x by root over 1 minus x squared. So this is du by dx, plus is there, right? So dv by dx, and how much is that? So this is x to the power root over x by root over x into 1 plus half log x. Okay, so this is our dy by dx. So pause the video to note down. Okay, now we'll again do the same way here. Let me call this to be u, let me call this to be v, and let me call this to be w. Okay, and you can leave it as it is. So again differentiating both sides with respect to x, so you'll get du by dx plus dv by dx plus dw by dx equals to, now differentiation of this is how much? It is 0, because a to the power b is a constant. So that's why differentiation of constant is 0. Now our aim is to find these three things. So we have u equals to y to the power x. Okay, so both the base and power both are functions of x. So that's why I need to apply log. So when I apply log, I'll get log u equals to x log y. Now we will differentiate here. So you'll write differentiating both sides with respect to x. So differentiation of log u becomes 1 by u du by dx equals to, now this again f into g, so that's why it becomes x d by dx of log y plus log y into d by dx of x. Simplify this further, so you'll get x, now differentiation of log y is 1 by y dy by dx plus differentiation of x is 1, so that's why it is only log y here. So we have du by dx equals to, okay, so u goes here and becomes multiplication. So what is the value of u? U is y to the power x. So y to the power x into, this is x by y dy by dx plus log y. Okay, similarly you will find dv by dx and dw by dx, which will turn out to be this much. Okay, now if you call this as 1, 2, 3, and 4. So you can make use of 2, 3 and 4 in 1 to get. So let's see what we get. So therefore I'll get du by dx as y to the power x by y dy by dx plus log y plus dv by dx. It is x to the power y by x plus log x dy by dx plus dw by dx, that is x to the power x into 1 plus log x is equals to 0. Okay, so next step what you are going to do is you will open the bracket by multiplication, and wherever is dy by dx you will keep them aside and take out dy by dx as common. So when you do that you'll get, so you have dy by dx as common, so I have this contains dy by dx, so here we have y to the power x, and this thing is together with dy by dx, so that can be kept in one side. So y to the power x divided by y is y to the power x minus 1 into x. Okay, so from here we get x to the power y plus log x together with dy by dx. So there's a plus sign, so we have x to the power y log x here. Okay, and we don't have any dy by dx term here, so whatever is left that will be sent to that side. So we have from here minus y to the power x log y. Okay, so plus is there, so it becomes minus over there. Similarly from here we get minus x to the power, so x to the power y divided by x is x to the power y minus 1 into y, and this whole thing, that is minus of x square into 1 plus log x remains here. So therefore your dy by dx, so therefore your dy by dx will be whatever is there, so that will be our numerator. So y to the power x log y minus x to the power y minus 1 y minus x square into 1 plus log x. Now whatever is here that will become my denominator here. So this is y to the power x minus 1 x plus x to the power y log x. Okay, so pause the video to note down. Now we'll try solving this particular question. So fx is given to be this much, and we need to show that f dash of 0 is equals to this much. Now f dash means the derivative of function fx. Okay, so basically we need to differentiate here, but what I see here is, here in the base we have got x, and similarly in the power we have got x. So whenever we get such cases we apply log on both sides. So applying log on both sides, what do we get? So we'll get log fx in the left hand side equals to, so this is my a and this is my b, so this b comes front, so a plus 1 plus 2x log of a plus x by 1 plus x. So this is log a by b form, and we know that log a by b is log a minus log b, so that's why we can write this as a plus 1 plus 2x. So we have log of a plus x minus log of 1 plus x. So after this what we do is we differentiate both sides with respect to x. Okay, so differentiating both sides with respect to x, I'll get 1 by fx for log fx into, now differentiate fx, it will be f dash of x. Okay, so here we have got f and this is my g, so f into g format is there, so this can be written as, first keep it as it is, differentiate this part, so a plus 1 plus 2x, and we need to differentiate this one. So differentiation of this g gives me 1 by a plus x for log. Okay, so for log I'll get 1 by a plus x, but we need to differentiate this inner part as well. So differentiation of a is 0, plus is there, so differentiation of x is 1. So similarly, differentiation of this gives me 1 by 1 plus x into differentiation of 1 is 0, plus differentiation of x is 1. So this is differentiation of g. Now we'll keep g as it is. So g is this much, which in turn can be written this much, right? So g can be written as x 1 plus x. Okay, now we need to differentiate function f. So d by dx of this much. Now d by dx of this much is differentiation of a is 0. Similarly, differentiation of 1 is 0. Now differentiation of 2x is 2 can be written outside since this is a constant, and differentiation of x is 1. So 2 into 1 becomes 2 itself, right? So we have a plus 1 plus 2x. Okay, so this can be written as 1 by a plus x minus 1 by 1 plus x, plus this is 2 plus 0 is 2, so 2 log a plus x by 1 plus x. Okay, now let me take this f here, so that's why it becomes f dash of x will be left here. So f dash of x is, this goes here and becomes fx. So what is the value of fx? Fx is a plus x by 1 plus x all to the power a plus 1 plus 2x into this full thing, that is a plus 1 plus 2x plus 2 log a plus x by 1 plus x. Okay, so we have found our f dash of x. Now we need to find f dash of 0. So at x equals to 0, so what do we get? Let's see. So we get f dash of 0 equals to, so a plus x is 0, so wherever x is there I'll put 0. So we have a plus 1 plus 2 into 0 is 0 itself, so a plus 1 plus 2 into 0 is again 0. Similarly, we have 1 by a plus 0 minus 1 by 1 plus 0 plus 2 log of a plus 0 by 1 plus 0. Okay, so this is a plus 0 is a by 1, so a by 1 is a, so this is a to the power a plus 1, right? Yes, so a by 1 is a, in the power we have got a plus 1, so a plus 1, so we have a plus 1 out there. So this is 1 by a minus 1 plus 2 log a by 1, that is a, right? Okay, simplify this further. So let me write this 2 log a in front, because in proof we have 2 log a in front. So a to the power a plus 1, 2 log a plus, let us simplify this. So we have, this can be written as 1 plus a plus 1 can be written as 1 plus a, and when I simplify this I'll get 1 minus a by a. Yes, so we have a to the power a plus 1 into 2 log a plus, now this is in one of the very important formula, that is a plus b into a minus b. So 1 plus a into 1 minus a, so a plus b into a minus b is a square minus b square, so this becomes 1 square, that is 1 square is 1, and a square, 1 square minus a square, that is 1 minus a square, by in the denominator we have a. So this is what we need to prove. So pause the video to note down. Now we'll learn about new kind of differentiation, that is parametric differentiation. Now in parametric differentiation, if you are asked to find dy by dx, then the equations for x and y will be given separately. Okay, so here we have x equals to function of t and y to be function of t as well. Okay, so whichever is the parameter here, this t is known as parameter, the same will be out there as well. Okay, now x and y will be given separately to you. Now whenever it is given in that way, then we'll make use of this formula to find dy by dx. Let's see how to do this. Now we have first example, find dy by dx when x is given to be this much, y is given to be this much. Okay, now since x is given to be this much, let me call this as 1. Okay, and y is given to be this much, let me call this to be 2. Okay, so differentiating 1 means this one with respect to, now what is the variable in this equation? The variable is t, so that's why I'll write with respect to the parameter, that is t. So let me differentiate, then I'll get dx by dt. So a is constant, so a can be written outside, so differentiation of cos t is minus sin t plus now log tan t by 2. So again here we have to use chain rule. So differentiation of log is 1 by tan t by 2 into, now differentiation of tan is sec square t by 2. So this is all about your log and tan function, but we have got t by 2 as well. So if we differentiate t by 2, then 1 by 2 can be kept outside and differentiation of t becomes 1. Okay, so this is my dx by dt. So you can simplify this further to get a minus sin t plus this half into 1 is half, so you can write it here, right? So we have sec square t by 2, and you can invert this to write cot t by 2. Okay, so this is my dx by dt. Similarly, I'll differentiate 2. Okay, so differentiating 2 with respect to t. So therefore I'll get dy by dt equals to, this a can be written outside, so differentiation of sin is cos t. Okay, so I have found it dx by dt and dy by dt. So in formula also we have got dx by dt and dy by dt. So therefore your dy by dx can be written as, using that formula, dy by dt divided by dx by dt, where dy by dt is how much? Dy by dt is a cos t divided by dx by dt is a minus sin t plus half sec square t by 2 cot t by 2. Okay, so you can cancel a and a, so whatever is left, that will be your dy by dx. So pause the video to note down. Okay, now we'll see how to find dy by dx for this particular parametric equation. Now here again the parameter is given to be t. Okay, so since it is given to sec, it will be easy for us to work with cos. So that's why cos will be just reciprocal of this. Okay, so this means cos x is equals to 1 minus t square by 1 plus t square to make our work easier, I'm going to do substitution here. Okay, so if I do substitution, let's see what happens. So what we substitute here is, let t equals to tan theta. Why, you will understand it. So if I get cos x to be this much, then I'll get 1 minus, instead of t I am writing tan theta, so I'll get tan squared theta by 1 plus tan squared theta. Okay, and similarly you have tan y is equals to 3 t is tan theta minus tan cube theta by 1 minus 3 tan squared theta. Okay, now cos x is equals to, from here, from trigonometry class 11, we know that this is equals to cos 2 theta. Okay, and similarly from trigonometry class 11, we know that this is equals to tan 3 theta. Okay, so from here, what do we see? We see that x is equals to 2 theta, right? Okay, and similarly from here, what do we see? Y equals to 3 theta. Okay, now let us differentiate x with respect to theta, because our new parameter here is theta, right? Because both x and y are depending on theta right now. Okay, so therefore dx by d theta, differentiating with respect to theta, you have to write. So 2 will get outside, so differentiation of theta with respect to theta itself becomes how much? It becomes 1, so that's why it is 2. So again from here I'll get dy by d theta equals to 3 d by d theta of theta, which is again 3. Okay, so that's why your dy by dx will be dy by d theta, new parameter, by dx by d theta. So dy by d theta is how much? 3 by dx by d theta is 2. So my answer is 3 by 2. Pause the video to note down. Okay, now let's see how to find dy by dx for such kind of functions. Here, before I begin, I would like to show you derivation of two very important formula, that is cos 4 theta, which we are not aware of from our earlier trigonometry. So cos 4 theta can be written as cos 2 into 2 theta, right? So if this is my a, then this is cos 2a, and this cos 2a can be written as 2 cos square a minus 1. And what is the value of a? It is 2 theta, right? So again cos 2 theta whole square is there, so again this can be written as 2 cos square theta minus 1 whole square. This means cos 2 theta, right, whole square. So cos 2 theta whole square is cos square 2 theta minus 1 is there. So when you apply a minus b whole square formula, then you'll get, after simplification you'll get 8 cos to the power 4 theta minus 8 cos square theta plus 1. So this is one very important formula which we need to know. Okay, so we'll make use of this formula, and one more formula we are going to make use here. Now another formula that we are going to make use here is sine 3 theta. Okay, so this sine 3 theta can be written as 3 sine theta minus 4 sine cube theta. Okay, so these are two formula which we are going to make use of. So pause the video to note down the formula. Okay, now you have to be very careful in this problem, because there are going to be so many manipulations. Okay, now if you see here in this x, let me call this as 1 and let me call this to be 2. We have got this one in first one. Okay, so if I put t to be cos theta from here, if I put t to be cos theta, then exactly this formula will come. Okay, so instead of this, I can write cos 4 theta, right? So I can write cos 4 theta here. Now here, if I put t to be cos theta, because in this earlier case I have written t to be cos theta, then I'll get 3 cos theta minus 4 cos cube theta. Okay, so it doesn't have any formula as such. Okay, so what we do is we'll try to see this problem. Okay, so if I take this t to be sine theta, then exactly I'll get sine 3 theta. Yes or no? Yes. Okay, but here I have taken t to be cos theta, and here I cannot take t to be sine theta because both the angles are same, right? So that's why here I'm going to do another substitution, and I'm going to take t to be sine alpha. Okay, and how to deal with it we'll try to understand later. Okay, so I'm writing let t equals to cos theta here, okay, and t equals to sine alpha. So I'm going to use this t equals to cos theta in 1, and I'm going to use t equals to sine alpha in 2. Okay, so therefore I'll get x equals to cos inverse 8. So if I substitute t to be cos theta, then I'll get 8 cos to the power 4 theta minus 8 cos square theta plus 1, right? So this is cos inverse, this is cos 4 theta, right? So this is cos 4 theta, so this is equals to 4 theta. So therefore I got x to be 4 theta, right? So let me call this to be 3. Okay, now similarly if I put t equals to sine alpha here, then I'll get y equals to sine inverse 3, t is sine alpha minus 4 sine cube alpha, right? So this can be written as sine inverse of, this is how much, sine 3 alpha, right? So this is equals to, so therefore y is equals to 3 alpha. Let me call this to be 4. Now here the parameter is theta, but here parameter is alpha. Okay, so let us differentiating 3 with respect to, so parameter is theta here, so with respect to theta, then I'll get dx by d theta equals to 4, right? And similarly differentiating 4 with respect to alpha, then I'll get dy by d alpha this time. Okay, so I'll get this to be 3. Okay, so here we have formula dy by dx equals to dy by dt dy by dx by dt. So this is the formula available with us. So this instead can be written as dy by dt into dt by dx as well, right? So we can write this as well. So if I use these two here, let's see what will I get. So I'll get dy by dx is equals to, I have, instead of dy by dt, I have dy by d alpha, right? Okay, and similarly instead of dx by dt, I have dx by d theta. So that's why instead of dt by dx, I can write d theta by dx. So d theta by dx. But if you pay attention here carefully, here we have got dt, here also we have got dt. Okay, so we have to match them. But here we have got d alpha, and here we have got d theta, which is not matching. Okay, so to match them, I am going to put one more term here. Okay, so and that is d alpha by d theta. Okay, so now if you match them, you'll exactly get dy by dx. So d alpha and d alpha can be removed, d theta and d theta can be removed, so you'll get dy by dx. Okay, so we'll again find this new term, that is d alpha by d theta. Now from where do we find this? From here we are going to find, because we know that t and t both are same, so that's why sine alpha must be equals to cos theta, right? So from here I am getting sine alpha to be equals to cos theta, right? So let me call this to be star. Okay, so differentiating star with respect to theta. So let's differentiate with respect to theta. So differentiation of sine is cos, right? So cos alpha into differentiation of alpha with respect to theta is d alpha by d theta equals to, now differentiation of cos theta with respect to theta is minus sine theta, right? Yes or no? Now this cos theta in terms of cos alpha in terms of sine alpha can be written as root over 1 minus sine squared alpha. Yes or no? Okay, so we have d alpha by d theta here equals to minus sine theta, and we know that the sine alpha is equals to cos theta. So instead of the sine alpha I am writing cos theta. So I'll get 1 minus cos squared theta into d alpha by d theta equals to minus sine theta. And how much is this 1 minus cos squared theta? It is sine squared theta, and square root of sine squared theta is sine theta. So that's why from here d alpha by d theta, the d alpha by d theta is equals to minus sine theta is already there, and this is also sine theta. So this goes to the denominator and I'll get minus 1. So the value of d alpha by d theta is minus 1. So therefore your dy by dx will be this much. Let's see how much it is. So dy by d alpha is 3 into d alpha by d theta is minus 1 into d theta by dx, that is opposite of this. Dx by d theta is 4, and from here we get d theta by dx is equals to 1 by 4. So this is 1 by 4. So when you multiply them, you'll get minus 3 by 4 as the answer. So pause the video to note down.